Our next section is on magnetism. What is a magnet? A magnet is a material or object that produces a magnetic field. What is a magnetic field? A force that pulls on certain materials and attracts or repels other magnets. By classification of materials, if it's magnetic, it's a material which is strongly attracted to iron, nickel, or cobalt, which also repels or attracts other magnets. If a substance is ferromagnetic, it is attracted to a magnet, becomes magnetic temporarily, and becomes demagnetized if tapped. Non-magnetic means that it's not attracted by a magnet at all. In theory, only magnets and ferromagnetic substances are affected by magnetic fields. In a non-magnetized ferromagnetic substance, these domains are in random order, but when they're placed in a magnetic field, their domains will align in the same direction as the field and become magnetized. So here's an example: domains before magnetization and domains after. What is the shape of a magnetic field? This is a bar magnet, and the magnetic field usually goes from north to south of the magnet, from north to south. This is the shape of a magnetic field in a horseshoe magnet. Magnetic fields have the following characteristics: a north and south pole, as I discussed, and the line of force goes from one pole to the other. The most important thing here is that they start from the north and end at the south pole. The lines of force never intersect, and like poles repel one another, whereas opposite poles attract each other. So the law of magnetism states that like poles repel one another. Two north poles will repel one another. None of the lines of force will go near the pole, and the lines of force will go towards their own south poles. Opposite poles, however, attract one another. A north pole will attract with a south pole. The lines of force will always start from the north, as we had discussed, and end at the south pole. So attraction between magnets, for example, if this is north, would be attracted to the south. But these are the same polarity. This could be north and north, and south, and as you can see, they repel. Lines of repulsion. How compasses react to magnets, a very important topic. The red end of the compass needle is attracted to the south pole of the magnet. Therefore, the message is the red end of the compass is that of the compass's north pole. So if you place the compass in a magnetic field, it always points to the north. Electromagnetism is the joining of electricity and magnetism. Remember, magnetism has to do with the alignment of electrons and atoms. But when you have an electronic current, the motion of the electrons are going in the same directions. Therefore, electrons have the same orientation. When you have a dynamic current flowing, you produce a temporary magnetic field. Finally, let's look at the right-hand rule, which is used to determine the direction of the magnetic field line generated by the live wire. Your thumb points in the direction of the current. So it points from the positive terminal to the negative terminal, and your fingers are always in the direction of the magnetic field. So for example, in this description, the direction of the current is from positive to negative. My thumb points upwards, and my fingers or my fingernails point in the direction of the magnetic field. And if I were to place a compass here, that would point to the compass's north. Thank you.